HyperLynx SI Board Sim and Line Sim now support multi-board simulation in the VX 2.3 release. The topology for these particular nets we have selected is shown here in Line Sim. You can see that there's a daughter card and a motherboard. Zooming in on these nets in Board Sim, we will use the Analyze 3D EM pull-down to manage our 3D areas for simulation. The 3D Area Manager can easily allow us to automatically create 3D areas for our selected nets. We can also solve these highlighted areas with the click of a button with our 3D field solvers. Notice that the automatically found 3D areas are represented in BoardSim by blinking boundaries. The user can analyze and verify that their 3D areas are sufficient for their simulation, making sure to capture all the necessary vias, fanouts, breakouts, etc. for the various areas. Once they've been verified and solved, the HyperLynx Full Wave Solver tool allows the user to inspect these automatically solved 3D areas more closely. The HyperLynx Advanced Solvers tools give the user access to viewing in true 3D their vias, ports, and in general the different fan-out structures of each of these unique 3D areas. This particular tool is the HyperLynx Full Wave Solver HPC in the VX 2.3 release. Once we're done inspecting the 3D areas with the Advanced Solvers tool, we will return to BoardSim and make sure that we have enabled signal trace coupling, area fill coupling, and lossy simulation to ensure that we get the most accurate results from our simulation for this particular test case. We can view and verify the coupling region and separation of the nets with the stack-up features of BoardSim and view each of our individual regions for simulation. The HyperLynx Stack-up Editor allows us to choose our model type, the technology of each layer, surface roughness, etch factor, and etc. to ensure that we're simulating the exact PCB technologies that our customers produce. With the new multi-board features, we can view both the daughter card and the motherboard stack-ups for this project, as well as the backdrilling settings for each individual PCB. The connection editor dialog shows the ports for each respective board. Now we are ready to run the SerDes batch wizard and see if our nets are in compliance. The SerDes wizard streamlines these compliance checks, first by choosing which protocol to simulate, then making sure we have the differential pairs set up with the drivers and receivers, and then next sweeping for the proper range of frequency for the simulation. The final step in the wizard is the Output tab, where we will run our simulation. Once the simulation is complete, a report is generated. The HyperLynx Touchstone and Fitted Poles viewer allows us to view and analyze each individual port from the compliance simulation. The S parameters that are generated can be displayed in a variety of ways, with magnitude in respect to dB, as well as standard mode or mixed mode. The display window on the right allows the user to select the different ports. We can also inspect insertion loss plots from the interactive HTML compliance report. It provides mask checks and a very clear pass-fail indicator, as well as many other details. A near-end return loss and far-end return loss plot is also generated. In addition, there's a fitted attenuation plot as well as an insertion loss deviation plot. Time domain links and pulse responses can be analyzed with the click of a button. Voltage transfer functions for the short channel and the long channel are automatically created and have links to allow deeper analysis. A number of input parameters are displayed as well. There are filter options to easily find what you are looking for. Finally, a summary is shown of the channel operation margins and shows a clear pass-fail of each channel. All of this useful information was streamlined with the SerDes wizard, giving our customers not only the necessary tools to succeed, but presented in an effective yet easy to use manner.